Welcome to Crosstalk Solutions. My name's Chris, and recently I received an email from Nez out in the Philippines, and he says, "Hi, good day, Crosstalk. I'm Nez from the Philippines. I have a plan to set up a 35-kilometer point-to-point link expected with clear line of sight. I just want advice on what antenna I should be using in this setup." And so we're going to take a look at this. We're going to simulate this link. Now, Nez sent me the coordinates in AirLink, and we're going to take a look at his particular setup and talk about the different antenna options for this 35 kilometer, or which is approximately 22 mile point-to-point link over near Manila in the Philippines. Okay, so here is the link. On one side, we have a pretty high up on the hill, a link near Calamba, I'm not sure how you say that. And then on the other side of the link up here, so here's Metro Manila, Quezon City, but it's sort of like right here on the coast in this little sort of suburban neighborhood out there, out on the outskirts of Manila. Now, a couple of interesting things here. This link does partially go over water, so that's actually pretty good because you can, there's nothing to be in the way. We know that that's sea level and that's that. And then on this side, the elevation is actually pretty high. So if we look at the topography here, we can see that we're about 500 feet elevation on the Calamba side, and then we are down to right around 100 feet or so elevation on the Manila side. That's ground level. Now let's take a quick look at this in Google Earth. Let's start with the Calamba side here. So here's Calamba, right? And so this is basically the direction that we are looking. If I sort of bring it up a little bit, you can see scrolling this way, there is the second point right about where the hand is at the top middle of the screen. We're going over this body of water, and then we're ending up right here. Now, it looks like it's pretty flat in Google Earth. It's really hard to kind of tell, but this is about 400 to 500 feet above sea level at this location. The other location, however, is kind of interesting. So we're going to pop over here to the location that is outside of Manila. And if you look here, it looks, again, kind of just like a residential neighborhood, right? So let's sort of get some topography view here. And the one thing that concerns me about this spot is if we twist it all the way around and then look towards the other link, which is right about in this direction over here. Now, if we zoom in, you can start to see, maybe this is hard to see on YouTube, but you can start to see that there's actually, it's pretty hilly over here, right? So this, of course, is just the topography of the ground. We're not talking about trees or houses that are certainly going to be obstructions that are in the way. But notice that if you were just putting an antenna on the roof of this building right here, you're likely not going to have line of sight. So Nez, when he sent me the simulation, he has the Manila side up at 82 feet. So I don't know if he has a tower out there or some tall tree or something that he can get an antenna 82 feet in the air, which is about 25 meters, right? So does he have a 25-meter tower out there near his house? I'm not exactly sure. However, since he sent this to me as the device height 82 feet or 25 meters, we're just going to assume that he has some sort of tower out there that is going to get that antenna up that high. Because if I drop this down even a little bit, right, so if I keep dropping, boom, once we hit about 70 feet, or 72 feet or lower, we really see a massive degradation in the signal because this mountain here is basically hitting the Fresnel zone. If we drop it down even further to, like, say 50 feet, by the time we hit 50 feet, we have basically zero line of sight. Okay, so yeah, if it's up at 82 feet or 25 meters, we're looking pretty good as far as line of sight goes. The Fresnel zone seems clear. Again, keeping in mind that link.ui.com doesn't have any knowledge about buildings or trees or other obstacles that might be in the way of this link. Okay, so with all that being said, what are the options for this point-to-point link? And there are many different options. Some are going to be licensed options, some are going to be non-licensed options. To me, what I look for is the most bang for the buck in any particular situation. So let's start at the very low end. Okay, so this is the Rocket 5AC Prism Gen 2. That's this guy right here. So Rocket Prism AC. oops, where did it go? There it is. This runs about $209 for the access point, and then we're going with the Rocket Dish 31 dBi. It's the RD-5G31AC. And this dish here is $339. Okay, so this is a pretty powerful dish connected to the Rocket Prism AC. So this full setup is just about $1,100 US. And with this setup, we can expect a 100% signal out of the Rocket Prism, and we'd be looking at probably 545 megabits per second maximum. Now, of course, that's perfect scenario, right? I don't ever expect that I'm going to hit the maximum numbers that Airlink is telling me that I'm going to hit, but I could probably expect easily 50% of that. And so if 200 megabits or so is all that you need for this point-to-point link, that's a pretty good setup for about $1,100. It's not bad at all. I mean, a 25-meter tower on the Manila side is going to be more than that amount of money, so that's not too bad. One thing I did want to mention, though, speaking of that tower in Manila, if you are faced with a situation like this, right, so see, you can't really see over these hills from this location, but what can see over these hills is this building right here, right? So if you are trying to get creative with something like this, you could perhaps go over here. This building is the Taguig, I don't know how you say that, excuse my pronunciation, the Taguig City University in Taguig City, I suppose. So you could potentially contract or lease space on the roof of this building, which would definitely have clear line of sight over to the other location. And then you could possibly even do like a point-to-multipoint distribution out to cover this entire neighborhood, right? So then you could possibly turn yourself into a wireless ISP instead of, just having a single point-to-point to this one spot here. Okay, so that being said, again, I'm not sure exactly what Nez's plans are for this whole thing, but let's take a look at the next antenna. And we're going to stay in the 5 gigahertz, but let's bump up to the AirFiber 5. Okay, so this is sort of an all-in-one unit. You have to have 2 of these, 1 on each side, and they're pretty pricey. These are $9.99 each. So what we're looking at here is about a $2,000 solution. Now, what you can expect to get with the AirFiber 5 is about 60% of the capacity of the access points, or the radio set on both sides, with estimated 768 megabits per second. Now, to me, looking at this, it seems like it's basically almost twice the cost for not that much more benefit than the Rocket AC Prism Gen 2. So I probably would not go with the AirFiber 5 in this case. And again, we're also not factoring in any possible interference in the area. When you're talking about a very populated sort of neighborhood, there's probably going to be other 5 gigahertz stuff out there, and this requires a 50 megahertz channel width to get these speeds. So 50 megahertz channel width is a big chunk of the spectrum, right? So there's probably going to be some interference, some overlap there. You'd have to go out there on site and actually sort of run some tests and see what kind of interference are in the area, because that's it's probably a lot of 5 gigahertz interference. Okay, so we looked at the Rocket 5AC Prism Gen 2, we looked at the AirFiber 5. Let's look at the new equipment. So let's look at the AirFiber 5X HD. And we're going to go with the 30 dBi antenna. That is the AF-5G30-S45. It's actually this one. So there's the AirFiber 5 that we talked about. Then we have, this is the new stuff. So this is the AirFiber 5X HD. This is the device that I just saw in Wispapalooza a few weeks ago that was the new LTU technology. Like, this is the proprietary chipset made by Ubiquiti specifically for this LTU equipment. And here's the antenna that we're talking about. It's this middle one here. This is the AF-5G30-S45. They do have even a higher gain one as well. They have a 34 dBi gain antenna as well, but we're going to go for this middle one. Now, the interesting thing about this LTU stuff is we can actually bump up the channel width here all the way up to 100 megahertz, right? Again, which I'm not sure how well that's going to work, because now you're basically using up, a big chunk of the 5 gigahertz spectrum when you're doing that. But assuming that we could crank it up to 100 megahertz, we'd be looking at just over a gigabit. We'd be looking at 100% signal and just over a gigabit, or 1,094 megabits per second of expected throughput. Again, take that with a grain of salt. That would be in a perfect environment, and this is most likely going to be far from a perfect environment. But the cost of the AirFiber 5X HD, 2 of those, plus 2 of the 30 dBi antennas, is about $1,100. It's seriously about like $10 or $12 more than the Rocket AC Prism Gen 2 setup that we already discussed, and you have the potential of getting much higher throughput, almost like 3 times the throughput potentially with this setup. So to me, this is basically the ideal way to go if you're on a pretty strict budget. I would do this setup with the LTU technology over the Rocket AC Prism Gen 2, considering that they're roughly equivalent in price, and this gives you potentially a lot more throughput. So yeah, really cool to see this LTU technology up against some of the older stuff. All right, so there's 5 gigahertz, right? But what about higher spectrums, okay, where there's probably not going to be as much noise, there's not going to be as much interference. So for instance, here in the US, we have to license these spectrums. So you have to be a licensed operator, licensed with the FCC to use these different higher spectrums like 11 gigahertz, 24 gigahertz in the United States. I'm not sure what the rules are in the Philippines for these different spectrums that are, licensed spectrums here in the US. So we're basically just going to forget about all of that, okay? So I just want to look at the technology itself. We're not going to worry about the bureaucracy and the licensing and all of that stuff. Let's just look at, if you made an investment in 11 gigahertz or 24 gigahertz, what could you expect in terms of quality of signal as well as total throughput? All right, so let's take a look at that next. We're going to bump up to the 11 gigahertz spectrum here, and we're going to use the AirFiber 11FX. It's really the only choice we have. And that has a 35 dBi antenna. Okay, so here's the AirFiber 11FX, and here is the AirFiber X antenna. This is the 11 gigahertz 35 dBi AirFiber dish antenna, model number AF-11G35. So that's telling us that we could expect a 100% signal with about almost 1,400 megabits per second, so 1,376 megabits per second total throughput with a 56 megahertz channel width. That's the maximum, right? But it's probably not a very crowded spectrum, so you can expect to get a little bit closer to what you're seeing in Airlink when you are, when you can be sure that there's not going to be that much interference messing with your signal. But what about cost, right? So we have the AirFiber 11. Those run $600 each. Okay, so for these guys right here, where did it go? Yeah, for these access points, they're $600 each. You also need duplexers. So these reversible duplexers, you can have 1 or 2 of these duplexers on the AirFiber 11. It says each AF11X requires 1 or 2 duplexers sold separately, and the duplexers basically say it can use single SISO or bonded MIMO channels, depending on your specific licensing requirements. The AF11FX also features different channel widths to suit your deployment needs, and you can independently configure transmit and receive channel frequencies. Okay, so again, this is all sort of the licensed stuff. We're just going to assume that you would have 2 of the duplexers, you'd have the access point itself, and then the antenna. The total setup for 2 AF11s, 2 antennas, and 4 duplexers is going to come out to $2,754, or basically like 2.5 times the cost of the LTU equipment that we talked about. And that'll get you a nice signal, but it's really expensive, and this is not counting the hoops you'd have to jump through in order to get licensed to use 11 gigahertz. So again, take it for what you will. Let's see what else we can do here. Let's jump up to 24 gigahertz. And we're going to go with the AirFiber 24, just the standard AirFiber 24. They do have an AirFiber 24 HD as well, but let's just talk about this one here. The AirFiber 24 is a $1,500 access point. It is all combined with access point and antenna in one big unit. But we can expect a 33% signal and about 515 megabits per second for about $3,000 with this AirFiber 24. So to me, 24 gigahertz, just not the best option here. We're just going to chuck that one out the window. For kicks, let's look at the AirFiber 24 HD. It's a lot better. So it's 50% signal with about a gigabit of throughput estimated in 24 gigahertz. But yeah, again, to me, it seems like the best bet is going to be that AirFiber 5X HD LTU. So let's set everything back to that real quick. With the 30 dBi dish antenna, and we've cranked the channel width, 100% signal, just over a gigabit of throughput estimated. And yeah, so to me, if Nez is asking this question, what equipment, what should I go with for this point-to-point link? My advice would be try to get your hands on this new AirFiber 5X HD with the 30 dBi dish. Okay, hope you guys enjoyed this quick look at a point-to-point connection, a 35-kilometer point-to-point connection in the Philippines. If you have any scenarios similar to this that you would like me to take a look at, pop your information into AirLink, save it, and then send me the link, and I will take a look at it. I may even make a video about it if it is an interesting setup that I think other people would benefit from this type of analysis. And of course, take all of this with a grain of salt, right? Because every situation is different. Every point-to-point, point-to-multipoint link is going to be totally different depending on interference, topology, and 1,000 different factors. So just do your homework if you're going to be implementing one of these. This is a really good place to start researching, right? AirLink, but it's not real world because it doesn't take into account trees and, interference and, other obstacles that might be in the way. And if you guys are looking to buy any of this type of equipment, I will put some links down below. I'll put the links to the LTU stuff down below, and then we will just sort of forget everything else for the time being. You guys can click on those to see what that LTU stuff actually costs. And if you have any questions, put those in the comments below. I will answer them to the best of my ability. And if you guys enjoyed this video, make sure you give me a thumbs up. If you'd like to see more videos like this, make sure you click subscribe. My name's Chris with Crosstalk Solutions, and thank you so much for watching.